Hey there, it's Jason from Codemanship with another video diary entry. So I've been just digging through old boxes of flash drives and key drives and all that kind of stuff. And I happened to find on an old 64 megabyte key drive, USB key drive, a copy of some C# code I wrote nearly 20 years ago now. This would have been around late 2002, I think, that I did this. And it's a proof of concept for a project that I was working on as the architect. That's mainly what I did as an architect, is write the code. A proof of concept. So this is on ASP.NET, sort of classic ASP.NET with web forms, and inherently very difficult to unit test it. So I sort of spiked. There's the word we use in extreme programming. I spiked an architecture to demonstrate how we could make it unit testable and a lot more flexible. And you may well recognize many of the design patterns that are used here. Many of them come from patterns of enterprise application architecture, although this project predates the book, I think, the release date of the book, although many of those patterns were well known. And I thought it might be fun to spend a morning just digging through this code, partly because it's kind of interesting anyway to look at old code, because you get a sense of what kind of a programmer you were or what kind of an architect I was in 2002, and see how far I've come since then. And as you'll see, not a great deal has changed. There's been some progress, I suppose, but also just to sort of take you through some of these architectural patterns. So this predates the ASP.NET MVC framework that was specifically designed to make web applications using ASP.NET more unit testable. And so I thought we might just have a little dig around in the code just for fun, and see what we can find. So first of all, it's a web application, as you can see. I'm in the file system view in Rider, not the project view, because if I just switch to the project view, it's such an old solution. It just absolutely refuses to load them. So I haven't quite figured out how to get it to do that. So I'm not really a .NET expert these days. But let's go back to the file system view so we can actually look at the source code. So here's this web application. And the first thing you'll notice about it is that it actually only really has one ASP.NET web page, a single entry point to the application. This is a pattern called front controller. So the idea is that rather having different ASP.NET pages, and we could be talking about JSP or Java server faces or all kinds of other different technologies for doing these kinds of things. But rather than having one ASP.NET URL for each page in our application, we have a single entry point, a single page. This default one here. Let's just take a look at that. There's nothing really going on there in terms of layout or anything like that, because there's no real content yet. The content is generated using this framework that I threw together over the course of maybe 2 or 3 days. If we look at the code behind, let's take a look inside our C# code. This is the code that sits behind this web page. So there's a bunch of ASP.NET specific things. But the real business here is going on in the page load. So what I'm doing is I'm retrieving what's called an intercepting filter. This is essentially a chain of objects, a linked list, if you like, of objects that have different stages of web processing. So some are sort of doing pre-processing, which might revolve, for example, around authentication and access control. Then there'll be parts of that chain that actually execute the business logic. And then further down the chain, we're actually rendering the content. So the idea is that we have this sort of stateful view, this current view, and whatever the current view is that's currently held in memory in the user session, that will be rendered further down the stage. So intercepting filter is one of the patterns, I believe, that is talked about in Martin Fowler's Patterns of Enterprise Application Architecture. So the idea is that we set it up. We give it the arguments that are essentially the web context. This is our HTTP current context, so this is the real thing, as it were. And then we tell the chain to filter. So the first object in the chain does its job, and then it passes responsibility down the chain until every part of the processing has been done for that particular web request. So that's the kind of entry point to our architecture. Once we get into there, we get into this intercepting filter. So now we're into this. Let's take a look inside our viewlib. So this is the core code. I didn't rename that auto-generated file there, so silly Jason. But we can take a look inside there in a minute. So let's just take a look at this intercepting filter. Where are we? Where are we? Where are we? Somewhere, yep. So this is basically just an interface. I was not, as you can see, at this point, not really following the C# naming convention of putting I in front of interface, but I intercepting filter sounded a bit silly anyway. So it's just the idea that you have an intercepting filter. It has a filter method that takes a bunch of arguments that we're passing down the chain. So the web request and the web response and so on and so forth. And we can get the next one in the chain and we can set the next one in chain. So we're essentially building this linked list of different filters. So let's take a look at some of these filters. We've got, I think the first one is the authentication filter. And there's a bunch of access control stuff going there about users, who's allowed to do what, who's allowed to see what. A little further down, I should probably have packaged these up a little more smartly, put all the filters in one package, for example. Where's our other filters? So we've got a, it's not the render view filter, there's another one in here somewhere. Maybe it's that one. No, it's not. Somewhere here, authentication, where's the one? The event handler, yeah. So we've got like 3 steps at the moment. We authenticate the user, we handle the event, that's the second filter, so that's where the business logic kind of goes. And we're also setting up views at this point as well. And then we find, so this is where I got a bit clever, because I decided not to, what I would normally have used at this point for the different event handlers is the command pattern. So I would have wired together views and controllers, event handlers basically using commands. But I decided to experiment with delegates. So this was a relatively new idea, a new way of doing callbacks. So you'll see that our event handlers, when we get to it on our controllers, are all actually static methods. And it's just the methods themselves that we're setting up with delegates. So we're sort of building a little model view controller model, if you like, a little network of these things using delegates as event handlers. So you'll see that in a minute. So we get the event handler for the event that we're handling. So every request has, as part of the query string, I believe, there will be a thing saying, oh, this is the event, this is the action the user's performing. So then we'd go find the appropriate handler for that, which is just a static method, a delegate, basically. And the event handler manager there, there's exciting stuff there that just keeps a handle of all the events. It's just a hash table of events, delegates, basically. And then we've got a little further down, we've got this render filter, and there's a synchronized view filter. I've been trying to wrap my head. So most of this code, I'm quite pleased actually that a lot of this code does. I didn't have to sit there going, what on earth is this doing? So I am quite pleased with myself that nearly 20 years later, I understood most of the code first time on reading. But I'm struggling to understand this synchronized view filter. I think what it is basically is that we're getting a cached version of the current view. So the idea is our views are stateful, but in reality they're not. They're actually cached. The view states are all cached. So that we have to retrieve and go, well, when they perform this action, what were they looking at? And we go retrieve that view, and that then becomes the sender of the event, basically. So we're trying as much as possible to reconstruct a more kind of desktop kind of way of, a more Windows way of kind of doing it, where your event handler needs to know where the event came from, who was the view that it came from. So that kind of models that in that kind of Windows kind of way. So it's stateful in that sense. So I've just figured out what it's doing, explaining it to you. This is why we pair program, because sometimes the act of just explaining what your code is doing helps you to understand it. So at this point, so this would be authentication. Then we would synchronize the view. So in other words, what were they looking at when they actually click that button or perform that action? And that sets us up for the next one, because the view state contains, so for example, if it's a web form, for example, that they're filling out, we would be holding that view state, and we'd need to know that information. So it kind of models what web forms were doing in ASP.NET, because web forms were stateful in that kind of way. Then we have the event handler filter that says, okay, well, who's supposed to handle this particular request? And then they go off and find the delegate that does that. And the delegate essentially is the entry point, the top of our internal logic, if you like. Well, certainly the top of our sort of model view controller implementation. And finally, the clever part, the render view filter. So because they're not unit testable in the conventional sense, you have to be running in the ASP.NET process, which means you have to run it in a web server. We decided to go a different route with rendering. So we have these abstract views, and we'll take a look at a few of them in a minute. And these are then, the current view, basically, is serialized to XML. And then we have a whole bunch of XSL style sheets that can be applied to that. So we were using, this is how old this is. It's XSL transformations that we were using. But it turned out quite well in the end. It certainly turned out to be very, very unit testable. So that's kind of the processing stage. I went on to sort of progress from that to also having filters in other architectures where there's a step further down where persistence is handled. So for example, if we were using Hibernate in Java Enterprise, or if we were using nhibernate in .NET, which I used quite a lot, rather than handling persistence with the business logic, with the event handling, we would basically process the event in memory wherever possible. And then as a further stage down, we would then essentially commit that transaction to the database. So it kind of evolved a little bit over time. This, by the way, is enterprise, what we call enterprise architecture, in case you're wondering. All very highfalutin. Let's take a look at some of these views. So we've got views that represent essentially what the user is looking at. And they should also potentially represent what the user can perform. Selected field and some views, and it's so this is view model, basically. This is the view model pattern, and it's also the composite view pattern. So views can have subviews in the same way that, for example, in Vue.js or React, views can have subcomponents, or components can have subcomponents. So it's a composite view pattern that we're using here, and the idea is that events are essentially attached to views. So as we're rendering the views, there's also not just information about, for example, user inputs or things we're displaying, but information about actions that can be performed. And I'm going to try and figure out where the input event is. So the idea of an input event can be modeled, and we can say whether it's enabled or disabled, depending on the preconditions for that particular event and the state of the application at that point. So we build the views out of this information and also out of the input events that are available from those views. What actions can the user perform? So we decide whether to render a link or enable a button, and so on and so forth. So there's quite a lot going on here. I can't believe I did this. I was a lot faster than in a couple of days. So we got a whole bunch. And the idea is that every view inherits from this abstract view. I'm relying a bit too much on. I'm noticing that there are more comments in this code than I would normally write these days. I'm also, there's a few things here that are just habits, like, oh, you're probably going to need unique identifiers for all your views. So I was very much in the habit back then of giving everything GUIDs, whether they needed them or not, just in case. Just in case, for example, we decided we wanted to start saving this stuff to databases. In which case, names, I'm not keen on names used as keys or that kind of information, because things can go wrong. So that's probably why I did it. But Yagni, you ain't going to need it. We didn't need it. So the idea is we have this abstract view, and we can build views out of that. And as I said, each view has a list of events, the input events that can be triggered on that view, so button clicks and that kind of stuff. But they're all at a purely logical level, so they're not button clicks. They're sort of user actions represented at that level. And that's the basic idea. And then we have these controllers. So we have a controller here for handling login, for example. We always do login back in those days. And you can see we've got all these static methods like the login handler and the show login handler and the show basic search handler and so on and so forth. These are the things that we're going to set up as delegates, as our input event handlers, basically. So we're not actually calling static methods hard coded. Even that long ago, I wouldn't have done that. We're actually setting them up as delegates, so they're basically callbacks, function pointers, for want of a better word. And there's a bunch of helper stuff going on here and that kind of thing. And there's a bunch of test information there, mostly borrowed from various television programs of days of yore, Scooby-Doo, Monkey, and that kind of thing. So we've got all these different kinds of views that represent what the user can see and what the user can do. And the whole model view controller kind of pattern is set up between those views, between the event handlers, those delegates, and it's all sort of controlled through a single intercepting filter, or through a single filter. Okay, so there's all the stuff going on there. And then at the moment, a little further down, we look at the synchronized view filter and the render view filter. You can see basically that we get the current view from the cache, and then we render it. And then we have these view adapters. Well, there's one view adapter, and its job basically, based on a hard-coded URL, is to find, and a naming convention is to find the XSL star sheet that we need to apply to the render. So its job basically is to synchronize the view. That's where we do it there, I think. And then, oh no, that's the synchronizer. And then when we render it, where are we actually getting? Oh, the XSLT view handler, I think, is the bit that actually, finds the XSL star sheet, transforms it. Where's the bit? Oh yeah, we serialize it. So we have a view serializer as well, and its job. So there's quite a bit of back end stuff going on there. It was relatively speedy, actually. I was quite impressed. So the whole idea of doing this is that we could test our event handlers, we could test our views, we could test all of that logic. We could individually test our intercepting filters and so on and so forth using NUnit, which was relatively new back then. That's why we did this, because at the time ASP.NET MVC didn't exist. I'm sure at some point somebody was going to write it, but we had to kind of invent on our own. And that did make it, we did make it very, very unit testable. And just to prove the fact, if we go into our, I think somewhere we've got a test folder, we have indeed got unit tests for a bunch of this stuff. So we've got a test for identification, test for controllers, and so on and so forth. It's a spike, it's a proof of concept. So there aren't a lot of tests. If it was real production code, I would have written more tests. If memory serves, this spike code did indeed end up getting sort of fixed up. So we didn't rewrite it from scratch. We kind of fixed up, because this really is just a framework with some examples, views and stuff. So the framework part of it, I think we went on and we kind of added more tests and made it more kind of production quality. And it did actually get used in a real deployed app that was, at the time, successful. It did, of course, get completely replaced by a new version. And small world, it was actually my brother who led the team that built the replacement that, as he tells me, ended up being very much like what we did in the first place. So I thought it was kind of fun to go back over some old code, see how I coded then, see how it's different to how I code now. I would have used less comments and less sort of NDoc kind of stuff. I would have relied less on static methods. But there were some very useful things we did in here. And this is something that I'd learned to do very quickly when I was working on web applications. If we go down to another, somewhere in here, we've got another folder. Where is it? The context, the web context. So web requests and web responses and the web sessions, all that kind of stuff. So if you refer directly to the HTTP context objects in your ASP.NET code, then you kind of have to run it in a web server. Not the case with ASP.NET MVC. So what I did was I built a little wrapper. So I have indeed used the naming convention, iApplication. I created sort of simple interfaces that we could use to wrap the web context. And then we have two implementations, which I would in a real architecture, I would have put them probably in separate DLLs, separate projects. But we have the test version. So for example, we're just using hash tables. There's our test context. There's our test request, and so on and so forth. So we created a version of it that just stored the data that you would normally expect to get from the web, the HTTP context, and store it in memory. And then we got the real version that actually just wraps the HTTP context, as you can see. Excuse me. So that's really what makes it all much more unit testable, even at the front end. So we managed to unit test, really unit test, without having to run it in a web server, the vast majority of our code. I recall at the time we also did develop, or I developed a helper library for testing, for automating NUnit tests that work through Internet Explorer, through the API of Internet Explorer, so we could actually drive them from the front as well. So we did quite a lot on that project that would have proved useful, I think, to other people. And so looking back, maybe I could have worked more on this, and maybe we could have open sourced it. Maybe this could have been the new ASP.NET MVC. Who knows? But in case you're wondering where these kind of frameworks come from, in the early days, it's born out of necessity. It beggars belief that Microsoft and many other companies that develop these web programming, these web UI frameworks, didn't occur to them that people might want to unit test that code. It speaks volumes, really. Of course, they've cleaned up their act since then. But back in the bad old days, you had to kind of roll your own, which is a great thing, rolling your own, home-baked, as I call them, home-baked MVC frameworks, home-baked testing tools, and all that kind of stuff. Because even if you're not going to use them in the real world, I think there's good experience to be gained by writing one for yourself and seeing what kind of stuff goes on under the hood. So there you go. There's some old code. Interesting for a bunch of reasons. It did, of course, get completely replaced. I had forgotten that I had this and that it was on there. So it was kind of a nice surprise as I dug through some old files to see that. It's always nice to sort of stumble across old work that you did and compare it to the present day. Anyway, there you go. There's some old C# code. I hope that's given you a bit of a laugh and maybe food for thought. Hope you're staying safe. If you're enjoying the video diaries or the tutorial videos that I occasionally post, then ring the bell for notifications and subscribe to this channel. Highly recommended, of course. Stay safe until the next video diary.